so that we can start the class. It's raining here, sir. Maybe they have some network issues.
So, good evening, students. So, we have waited 10 minutes. Still, only four guys are available, right? Yeah. Okay, let's start with the previous model. We'll start discussing about the previous model. Um, Meanwhile, your friends will join. Yeah. Okay. Share my screen. So, students, how are you all? Yeah, hope everything is fine in Hyderabad. No traces of third wave since. Let's hope for the best. Take care of yourself. Okay, so in last class, there was some issue, yeah, with this grip. So anyone tried this? There was some issue with the sketch, and I said I'll modify it later. Okay, and we carried on with the sheet metal part. I showed you how a sheet metal part can be done using a shell operation. Yeah, using shell operation. We already saw that. Okay, so I'll show you what was the problem in the sketch actually. So let's have a look at this sketch. So whenever you come across such cases, like if you want to create a rib between two cylindrical parts, or especially cylindrical parts, so remember that. So we created a line starting from this face to this face, right? And then also extend a little bit, extend this horizontal line, okay, or draw a line which is horizontal, okay, and extend and leave it. Just say how much is this? Let us say just 5 mm is okay, okay, 5 mm extend and leave. Even here the same thing, 5 mm. Okay, in this case, let's check our sketch analysis. It's open because open profile is okay for stiffener. So it's okay, no issues with that. You can come out, okay. There, okay. So there are two methods actually. If uh, they ask you to use stiffener, this is the method, okay. So connect from this end to this end, and then just extend a 5 mm horizontal line. Here also same, here also same. Please remember that, okay? It will help you to uh, construct stiffeners when you are working with such kind of parts. And one more method without using stiffener, you can what you can do. Let me just deactivate this. Okay, I'll show you. So without using stiffener, you can you also can do like this. Okay, but for creating a rib, stiffener would be the best method. Okay, but in case if they sometimes they say that don't use stiffener, use normal pad and pocket methods. Okay, it depends what is their requirement. Okay, if they ask you to create using only pocket and pad method, then you have to create a profile like this. Okay, from top view, because from top view only we can get this profile. Okay, so we have to create a profile like this, and then when you create a profile, okay, then next you'll be using pad definition. Okay, create a profile using this surface. Okay, this surface, and then you can extrude it till next. Okay, what is the dimension you can see, and you can extrude it till there, and then use pocket operation to chop it. Okay, to get this shape. You can see, so this profile is created, and this much material is cut. So you got this shape. Okay, when you remove this material, then you can get this shape. Okay, this is one method and this is one method. Usually if you are creating a rib, then yeah, if you are using a pad and pocket, then these are two steps to minimize the methodology. We can in one method, one step we can finish it. So this is the stiffener is the one method. Okay, as of now I'll consider stiffener. Okay, deactivating this. I'll activate this. Okay, so as of now let's consider stiffener. This was the issue in last class. This is all. Hope you people tried for this, right? Anyone tried for the stiffener? Any difficulties in this while creating stiffener? Anyone tried? Any experiences? You can share this. Okay. So let's close this. Guys, any questions on this? So this was clear, right? In last class we did this and only stiffener was the issue, and I cleared it now. Okay. So in two ways we can create it, either using pad or stiffener. So if you are using a stiffener, then remember that surely maintain a horizontal line here, so that sometimes it considers stiffener considers the profile only when you have a horizontal line here. Okay, so you need to remember that. Okay, okay, guys. Then let's move on with today's part. So this is a simple part we have today. Okay, please take 2 minutes and just have a look at it and let me know if you have any questions. So same questions from my side. So what is the orientation of this part? What should be the orientation, and where we need to consider the origin? Okay. And what is the manufacturing process? It's again the machine manufacturing process. Okay. We'll also see one sheet metal part as I shown you in last class, sheet metal part. We'll see one sheet metal part also today and today's class. Please have a look at this, guys. Can you see the screen? Is this audible, visible?
Yes, sir.
My voice is audible, right? Okay, good, good. So please go through this and answer my questions. And guys, be ready. You people have to start modeling. Okay. So I'm going to give you the simple models which we already done. Okay. The same models I'm going to distribute, and I think you people have to form a groups and then select your parts which you want to model, and then you start modeling them. Uh, the timeline and everything will be communicated to you by Joy sir. Okay, I'll let you know at the end of this class. Okay, so how can we consider start messaging me if you want to answer my questions, or you can tell me where we can consider the origin and which is the front view. Here no arrow direction is given, so what is your opinion? Which one we can consider as front view?
75 centimeters
Sorry,
from the left side.
left side. Yeah. As we discussed, the basic rule is like where you can see maximum details. Okay, so this view you can consider as front view. That's fine. So, and the axis where we can place the axis system origin. What do you think? Where we can place? Please remember our discussions. Okay, so which area is important? What exactly is the purpose of this part? Okay, can you guess purpose behind this part? Like why this is designed? What is the purpose of this part? So which part, which area of this part is important, and that there we can place the origin. Okay. Any answers? Any guess? Just basic information. Okay. So what do you think? What is the purpose of this? This is the base. Okay.
This is to hold pipes, sir.
Something, some pipe. It's
Yeah,
going to put some pipe here. Okay. So
for
this area
cutting
is
stuff
yeah.
to hold it in a
Yeah.
place.
Exactly. So this area is important for us. Okay. So they are going to mount it on something. Okay, maybe this will be mounted on something and welded. Okay, that information is not available with us, but let's assume that some this base will be mounted or welded onto some other part, and this location, okay, some pipe or some tube is coming and sitting over here, and this point is very important. Okay, these dimensions should be maintained perfectly so that the alignment can be perfect. Okay, as per the requirement, if that pipe should come and sit properly in this area. That means there will be some tight tolerances for this, so that they can maintain the relationship between this part and the, maybe that part is rotational, that is rotating. We are not sure in this diagram, but in that case they have to maintain perfect, so that the axis, this axis should coincide with the pipe axis. Okay, and this dia should match with the pipe dia, so that it perfectly can come and sit here. Okay, so this area should be designed properly. So in that case, so can we consider the axis of this as the origin? Okay, so if this is the our front view, then this is going to be our z axis, and this is going to be our y axis as per present Catia. Okay, let's insert axis system, and here default, we have default axis system like z is our vertical axis and y is horizontal axis. So this point we are considering as this point. Okay, this point, this is our z and this is our y, z and y. Okay, okay, let's proceed with this. So I selected this plane. Okay, always position sketch. Okay, orientation. So this is what I'm looking for. So I'll keep it intact. Okay, and now, so where I'm going to start now? So I can start in this side view. Simply I can start complete profile, right? Am I right? So this complete profile is visible from the front view. Okay, this complete profile. So we can start from
Yeah,
here.
okay, sir.
So I'm going to consider this as the dia of this
40. No, sir.
41,
15,
any
15,
guess?
23,
Sorry,
23,
43,
23,
42,
23, sir.
so
46, sir. Diameter.
we have two circles, right? I'm directly okay, let me follow my rule. Okay, so we have two circles, right? One is inner, that is the thickness. Okay, another one is outer. Okay, so now if you see, what is the inner diameter?
30. 30, sir.
Sorry,
30, 30.
30, exactly, 30. because from this point to this point it is 15. That means simply he's showing the radius of this inner circle, right? Maybe he's not indicating it like R15. Okay, here he's showing the distance from here to here. That is nothing but radius of this. If radius is 15, dia is 30. Okay, dia of this inner circle is 30. And how about the outer circle?
46, sir. 46.
This is nothing but 8 mm thickness. Okay, so either you can do that, okay, or else you can simply, to match with the drawing, your sketch to match with the drawing, you can simply say 8 mm offset. Okay, say 8 mm and see what is this. Let's delete this. Now this is 8 mm offset. Okay, as per drawing, from this from this 8 mm offset. So this is 8 mm. Then what is it's 46. Okay, the reference, right? Okay. Now, so we need only half, right? Half of this circle. So we have to cut this into half. Okay. So for this, what we have to do, take a line, vertical line. Okay. Either you can use this or either say mirror. Like this. Okay, got the line here. Okay, so we have these two lines here, and now we need to, let's trim them. Trim it, trim it. Okay, so we click on this trim, trim, trim. Okay. This you can isolate. Okay, we can, okay. Now this portion is done. So what is required? This thickness we have to maintain. Okay, what is the 9 mm? Okay, so here thickness of 9 mm. Simply draw a vertical line here, a vertical line. Okay, say this is 4.5. From here it is 4.5. And similar. Okay, this is 9 mm. Okay, now what is the distance from here to top surface? Okay, here to, let's take a horizontal line and they are saying that from this surface, this face, to this top surface of this base is 40 mm. Okay, let's maintain this 40 mm. This is 40, 40. Okay, now what is the thickness of this? 9 mm. Here. Like this. Say 9 mm offset 9. Okay, and now this is 76. This is 76. This point and this point must be symmetrical to this. Okay. Same thing, we have to close this, take a vertical line, and also we can close this.
Sir, the long distance is 25, right?
Sorry,
The long distance is 75 base, sir.
sorry, I'm not getting.
The baseline is 75, sir, not 76.
This baseline,
Yeah,
you're talking about this baseline is 76. Okay,
the diagram showing is 75.
75, sir.
oh, this is 75.
Yes, sir.
Okay, 75. Okay, okay. Maybe it's not clear to me. Need to change my intervals, change my number. Thank you guys. Okay, now let us trim it. Okay. Okay. This is done. This is done. Okay. What else is here? We need to trim it here. No, this and this on. And then now simply take this and this. Okay. Now extend these things a little bit down, down. Again, you can one, two, done. Now to connect, remember to connect this to just to delete this. Okay, just to cut that. Again, double click and just click on this and click on the vertical line. Okay, vertical line. This will get connected. Okay, trimming and connecting both will happen there. Okay, now let's have a look at this sketch analysis. Closed and everything is fine. Okay. Okay, guys. So any doubts in this? Oh, everything is clear. Okay. All the dimensions are maintained here. The 8 mm, fine. As per this is inner one is 30 mm. Okay. Okay, this is 49. Okay. 75. And what else here? So this is 33 is saying. Okay. So is this 33? Let us check once. Is this 33 from here to here? Perfect. Okay, let's keep this. as per drawing here. So from this surface to this surface, it is 30 degrees. Okay. So this is also good, and this is actually 9. Okay. So let's show 9 here and say reference, or we can delete it. Okay. Let's say reference. 9 mm here. This is done. This dimension achieved. This dimension 8 mm achieved, and this we are going to get it in next step. Okay. So whatever we can get in front view, we have already achieved, right? Anything missing?
No, sir.
Everything good. Okay. Okay. Good to go. Right. Let's know how much we need to extrude. We need to extrude 52 mm. Am I right?
Yes, sir.
52 mm. Okay. So 52 mm. So we have considered axis here itself. Okay. So from this face, 52 mm. Okay. Save it. Add option. Okay. 52 mm. Reverse direction. Okay. Then, so this is achieved, and now we have to do this thing. Okay. This right here. We have to get this done. Let's work on this. So, what do you think? In which view we can do this? Another way.
From right side.
From right view, in the sense from here.
Yes.
So let's see. You said right view. Okay. Okay. So this is my right view. Okay. Should I explain? If I take it, if I consider this plane. Okay. This is my sketch. Okay. So here I'm going to okay. Then on which face you want to do that? See here, only this much is visible, right? So is it possible to get all these things, all this material? Both sides we have the same thing, right? So this portion we have to get. This portion of material completely we have to get it, okay? From here to here, even if you want to create and draw this line, then you have to create it from which direction? Any other answers? Just think for 2 minutes and tell me. I showed you the side view. Okay, side view. This is how we can get. Okay, you cannot get this angular thing. This is at an angle. Okay, this is not straight. This is not straight. This is at an angle. Okay, so here if you see this edge and this edge, disconnecting this edge and this edge. So where we can connect this edge, both edges, from which direction we can do that?
Copy, sir. Can you give it in copy? Top view.
Top view. Okay, let's
Yes.
so this view is not possible. Okay, let's delete it. Now let's go for top view. Okay, which is top view. This is our top view, right? So top view means this is our parallel plane for top view, XY plane. Okay, let me consider top view. Okay, so let me swap it, reverse it. This is my top view. Okay, so from top view, if I take some profile here, okay, maybe both sides I need. If I take something like this, I'll be getting something like this. Okay, and then I have to cover all this material. Okay, so is it possible? Let us see. If I extrude reverse direction, this is how I'll be getting. Okay, okay, so maybe this we can remove. Okay, okay,
Sir, can we try rib for the stiffener?
from here to here we can remove. From here to here we can remove. Okay,
Sir,
good. Yeah, please.
can we try stiffener for that?
Yes, we can try stiffener also.
Okay.
Can try stiffener. Okay, and also because this is supporting both sides. Okay, we have this side as well as the other side, so that's the reason either you can take this profile. Okay, this profile is visible from front view. Either from this side you can do it, or let's try stiffener also. Okay, so this is also correct method. Okay, what you said top view. So what we followed for the previous model. So for that, I showed two methods. Okay, one with the stiffener, one another with the same thing. Top view, take add the material and then remove the material so that you can get this exact shape. Okay. Anyhow, we can remove this material. Okay, we can remove this also and this also. Cut, cut here and remove this. Then you can get this shape. Okay. Okay, let's try in different method. This is one method. Okay, let's consider this as one method, and let's so 8 mm is the thickness, and exactly this is at the center of this. Okay, that is what we have to assume. No other things are given related to 22 mm from here. Okay, that is given. Let us see 22 mm from this end, this edge. So let's consolidate, convert it to 6. Okay. From here to here it is 22. This edge is 22 and the thickness of this is 8 mm. Okay. And this should exactly coincide with this line. Okay. This
Rupees 20 received on phone pay.
it. Okay. Same thing. Let's mirror it. is our line. Let's delete this horizontal vertical line. Send this and close this profile, close this profile. Now, if you come out, now simply remove this material. Okay, remove this material. Okay, this one. And also we have to, we want only these two things. This, from here. This is one thing. Right. Wait, this should be, this must be concentric. Yeah, not fix. Say this must be concentric. Concentricity. Okay, these both are concentric. And what is the radius of this? Okay, this is done. Now, how to constrain this? This from here, done. Now, this angle should be controlled. Okay, this angle, yes. This and the axis. Okay, axis. Now, control and fix it. Guys, you understand how to constrain it, right? I'm not explaining because we did many models which we constrain. Okay, this is how we have to constrain. Got it, guys?
Yes, sir.
So, anybody, any questions on constraining? Do you have any questions on constraining? How to constrain? If you have any questions, please let me know. Okay. Always the sketch should be green. Huh? Then only the sketch is valid.
So,
Yeah.
sir, can you say why, when should we use that fix option and isolate options? Isolate and fixing.
Ah, yes, yes. That's very important. See, if you are creating a part just like that, so if your part is not moving, in the sense, if you change the coordinates, your part should move along with the axis system. See, when you change your coordinates here, I'll show you how to change. In part model, when you double click on this center, you can see the XYZ coordinates there, 0, 0, 0. Okay. So when you change them, the part also should be able to move along with that. That means it only should have connection with the access system. When you extract something, that means when we have extracted so many things here, right? This whole profile is extracted from this solid. So this is the solid from where we have extracted for reference, isn't it? When I extract it, it is, see, look at this. This is yellow in color. That means this sketch is connected to this solid. Okay. So when this sketch is not connected with this axis system, but this is connected with this solid, that's the reason this is yellow in color. So we don't want any connection with the solid because we want to keep our part free so that it can move freely if we want to move it. Okay. So this sketch, complete sketch should be connected with the axis system so that only with axis system, not with the part, with the solid body, so that when we change the coordinates, this can move along with this axis system. Okay, I'll show you how to change the coordinates. Okay, as of now, that's the reason we always isolate it. Okay, see how to isolate, you know, right? When this is extracted, then immediately right click on that, say mark one object, and then say isolate. Okay, this will ask you this warning will come. Okay, you have to say yes, then this will be isolated. Then you have to start constraining is the sketch with the axis system. Okay, that is the right method, and that is the, we can say, best practices. Okay, so make a habit of that. Actually, if you are doing it, immediately start isolate it and just start doing it, constraining it with the axis system, so that you cannot have any problem even when you complete whole model. If you forget even in one sketch, then again you have to go back and search for the things where this is connected, where I have to delete it, okay, where I have to isolate it, and again you have to constrain it. Okay, these are simple models we are doing. If you're working on big models or assemblies, then you are surely going to face big trouble. Okay, it's very difficult to find out where you forgot to isolate it. Okay, where it is connected with the solid or some other body. Okay, so that's the reason we as a best practice, I explained this and I taught you. Okay, so please remember this. This is going to help you a lot. Okay, clear guys?
Yes, sir. Thank you.
Yeah. And one more short method, remember this. When you want to select whole sketch, right click on that and say auto search. Okay, go to that line. Okay, and say auto search. It selects whole profile and just delete it. Okay, okay, now let's have a look at this. So this profile is done. So this profile will be closed. We have to remove this material. Okay, material here and material here. Okay, so let's go here. So now we have to remove this material. Okay, we don't want, we want only this much. Okay, so let's close this profile. It's closed. Okay, this and this must be coincidence. this much material we have to remove. Okay. My material is up to here only. Okay. So I don't need to have very tight or closed circuit. Like I can extend this line so that I can cover whole material in that way. Okay, I'll show you what I'm talking about. This, and this is my construction line. Okay, this line is closed. Now, if you look at it, only this much material I have to remove. Okay, this much material I have to remove. Now, select hole. I need to mirror this because even I have to do the same thing here. So that's the reason I'll mirror this. Okay. Now let's have a look at this sketch. So this is my total sketch. Okay. 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 This. This both points. Okay. Let's have a look at the sketch analysis. What it is saying? This is closed. Closed. Okay. No problem. Closed. This is closed. Okay. Now let's come out. Remove it actually. Okay. Got extended here. It should be we want this up to here only, right? From this space to this. This only one. Okay, so this is merging. Okay, guys, got it?